Welcome everyone. Today we are going to learn about depolarization in more details. In my previous video on action potential, I have mentioned that depolarization, repolarization and hyperpolarization, these three membrane potentials make an action potential. Now this is resting potential. That means the membrane potential present in an unexcited neuron is called resting potential. Now one thing I want to mention, actually I want to briefly recapitulate that all the four different membrane potential is generated due to the movement of ions, a particular ion. Now ion moves through ion channels, open ion channels, and it moves from higher to lower concentration. Remember this. So that means there is a ion concentration difference inside and outside of neuron, and this is called ion concentration gradient. This is the chemical force that helps in the movement of ions and that generates membrane potential. Now, this ion concentration gradient is generated by the help of ATP-driven pump. So the first kick comes from the ATP-driven pump. Now, there are different ATP-driven pumps present. These are transporters that hydrolyze ATP to get energy to pump ions, and that generate ion concentration gradient. I am taking here one example, sodium potassium pump. Now these three ions I have written here the concentration difference because these three ions are the major contributor for the membrane potential of neurons: sodium, potassium and chlorine. Now through this sodium potassium pump, sodium export occur and potassium import occur. As because this pump export sodium, so the outer concentration of sodium is higher, 144 millimolar, and inside concentration of sodium is lower, for 12 millimolar. Okay. And in case of potassium, as because import occur, the external concentration of potassium is 5 millimolar and the internal or cytosolic concentration of potassium is higher, 155 millimolar. The chlorine concentration is higher outside and lower inside. I have not drawn the ATP-driven pump for chlorine, but this is the concentration difference. There is also one ATP-driven pump present that actually generates the ion concentration difference for chlorine. Here, as you can see, sodium will move from exterior to the cytosol because the concentration of sodium is higher outside, so it will move in these directions. And in case of potassium, as because potassium concentration is higher out inside, so it will move from inside to the outside, and chlorine, it will move outside to the inside. So this is the general movement of ions. It moves from higher to lower concentration. Now I have made a separate video on resting potential. That in that video I mentioned that Alan Hodgkin and Bernard Koch in 1949 proved that this potassium ions is responsible for the generation of resting potential. Now also these two scientists in 1949, by performing the same experiment, they proved that sodium ion is responsible for the generation of depolarization. But before that I go to that experiment, I want to mention the first point, which is that membrane potential of neurons when become more than resting potential, we call it depolarization. Now Alan Hodgkin and Bernard Koch in 1949, they take the help of squid giant neuron, and they actually perform very simple experiment. I have discussed in my resting potential video. I want to mention here also that they change the concentration of these three ions because they actually knew that there is a ion concentration difference is present, and they knew that due to the movement of ions this membrane potential is generated. Now which ion is responsible for particular resting potential or depolarization, they didn't know. So they did a very simple experiment. They just simply changed the concentration of exterior ion concentration. Like as because sodium is higher outside, so they lower the concentration of sodium and they observe what happens in this resting potential or depolarizations. The same is true for potassium, as because it is lower in outside, so they increases the potassium concentration and they decreases the chlorine concentration as because outside is higher. So they observe what happens in this membrane potential. As because I have mentioned in my previous video resting potential that when they change the concentration of the sodium and chlorine, very little amount changes in the resting potential, but when they increase the potassium concentration, the resting membrane potential changes. That means potassium is responsible for resting membrane potential. But when the changes the sodium concentrations or lowers the sodium concentration, they found it reflects with the depolarization potential. That means the sodium ions is responsible. I want to mention another time that when they decrease the sodium concentration outside, they found that resting memory potential is not changing, but the depolarization value is changing. That's because you can see here the peak value of one action potential is plus 15.8 millivolt. Okay, but when it changes the concentration of sodium outside or lowering the value of sodium concentration, they found that now the amplitude, this is called the amplitude of the action potential, decreases amplitude. And this is not with chlorine, so sodium is actually responsible for depolarization. By this simple experiment, by just lowering the sodium concentration, they got that the value or amplitude actually decreasing. Not only amplitude but also frequency of action potential is also changing. That means it is getting lower. Frequency means how many times action potential occurs. So when they decrease the sodium, they got this result. Now one thing I want to mention here also, in my previous video resting potential, I have mentioned one point called equilibrium potential. And by this equilibrium potential, we got this value by Nernst equations. So in that video also I have mentioned that by Nernst equation, we got a value of equilibrium potential for potassium ions. We call it Ek. And we got the value of Ek is approximately minus 98 millivolt, that is very close to minus 70 or minus 90 millivolt of resting potential. This is called equilibrium potential. Now, equilibrium potential is a membrane potential at which there is no net movement of ions occur. Now I want to mention here, now ion concentration gradient is a chemical force that helps in the movement of ions. As because ions carry charge, when they move, they also establish a voltage difference. And at a particular voltage difference, the ion movement actually stops. Why? Because the chemical force and the electric force just balance each other or equilibrates. That is called equilibrium potential. So the depolarization can move up to that point when there is no further movement of sodium will occur. That is called the equilibrium potential. By Nernst equation, we can derive the value of the equilibrium potential for sodium, and we got a value approximate plus 15 millivolt, and scientists observed that the peak value or amplitude of action potential is also plus 15 millivolt. Hope this video will help you. If you have any doubt about this topic, you can write me in the comment section. Thank you for watching and always keep learning.